Hi everyone, this is Hussein from EJ Academy. Thanks for watching this video. So in this video, I wanted to explain how you can use one of the libraries in Python to draw a 3D surface. So the problem is about a calculus problem that I solved in previous videos. I put a link probably above or below this video. You can watch those videos to get more familiar with the calculus concept. But in this video, I wanted to show you how you can use Python libraries to draw this 3D surface. So let me read the problem statement first. So in the problem that I solved in the previous video, we found a volume of a solid. The base of the solid was enclosed by a parabola with this equation, y equals 1 minus x squared, which is this parabola here, and also the x-axis, this axis here. And the cross-section perpendicular to the x-axis are isosceles triangle with height equal to the base. Let me explain the cross-section a little bit more. So you are looking here on the left, you are looking at the base of this 3D surface is shaded in green, and this is the x-axis, this is the parabola y equals 1 minus x squared. And here in blue, I'm showing an arbitrary cross-section at distance x from the y-axis. On the right side, you see the cross-section. The cross-section is isosceles triangle. So the cross-section is somewhere here. And so the z-axis is perpendicular to xy plane. So in the cross-section, you're looking at y-z coordinate system. And this triangle is isosceles triangle. Height is equal to the base, so h is equal to b. And so I wanted to show you how you can plot this surface in Python. So before start coding, I also prepared, so here you're looking at some calculation that I basically showed how you can use another library in Python. It's called SymPy to calculate the volume using Python libraries. Let me see if I can make this. Oh, apparently I cannot. I was trying to make the font a little bit larger. Before I start coding, we need to do some calculation to find the coordinates of the points that we wanted to basically draw a surface going through those points. So here, using dashed line, I showed the base of this surface, the parabola, and also the isosceles triangle. This is an arbitrary section, and I need to basically be able to calculate the coordinate of these 3 points. So let me go back to the 2D graph. If we look at the triangle on the right side, we already know the coordinates of the 3 points of these triangles. So this point here is at 0, 0. It's on the x-axis. And then this point here on this side is at the distance b from the first point, and this point is located on the parabola. So this point is, for these sections or triangles is on the parabola. So for example, for this triangle is here. So we know the coordinate of this point. So this y here, y coordinate is equal to b, the base, and we know y is equal 1 minus x squared. And the z obviously is 0 because it's on the y-axis. And then this apex here at the top is because this is an isosceles triangle. So this point here is that y coordinate is half a b, and then z coordinate is h, and we know h is equal to the b from the problem statement. So knowing that, so I'm trying to find the equation of these 2 lines. I call them line 1 and line 2. For line 1, this line is drawn between this point at 0, 0 and this point at half a b and h. The slope is equal to 2. I'm going to use, I use this general equation for line z minus z naught equal m times y minus y naught. Z naught and y naught are coordinates of an arbitrary point on this line, and m is the slope of the line. So I know the slope is equal to 2, and then for z naught and y naught, we can use coordinates of either of these 2 points. I use this one because it's easier. And I plug those coordinates here, and this is the simplified version of the line equation, z equal 2 times y. For line 2 is between half a b and h, and b and 0 is between these 2 points. And again, the slope is -2, and if we use the general equation for the line, plug in all the parameters that we know, we get the equation of line 2, which is z equal -2 times y minus 1 plus x squared. So having these 2 equations, let's start coding. So to start coding, I'm in one of the Colab notebooks. So again, to open up a Colab notebook, you can Google Colab, and then you go to this page and then open up a notebook. So if you click on Open Colab, so you are going to direct it to this page, and then you start with a new notebook. So I already have the notebook, so I'm not going to create a new notebook. So I'm going back to my notebook, and then I need to, because we are coding, I need to insert a new code cell. If it was just a text, I insert the text cell, but this is a code, so I'm going to insert the code cell. Now, so we need a couple of libraries. So obviously we need a math library. So I'm going to import math, and then import NumPy. NumPy is a library in Python that basically, if we are going to work with arrays and matrices and vectors, we're going to need that. So I'm going to import that library because I'm going to store all those node coordinates in a NumPy array. So I'm going to import that as np. And then or I can do it later, actually. So let me run this cell. So when I have this green check mark, it means that there is no error. I already imported these 2 libraries. So I'm going to insert another code cell, and then let me start by defining, let's say L is equal to 10. What is L? L is a parameter that basically defines number of cross sections along the x-axis. Okay, so it means that I'm going to have 10 of these isosceles triangles starting from this point at 1 all the way to that point, the other end at -1. Okay, then I'm going to basically define another variable x, and this is, I'm going to use line space from -1. Let me type this and then explain what it does. This is equal to L. So what I'm doing here, I am creating 10 points. This L is equal to 10. So I'm creating 10 points equally spaced from -1 to +1. So what that line does, it creates 10 of these green points, all of them on this x-axis. From -1, the first one, the last one is on +1, and then the rest of them are equally spaced in between. So we can print that to see what's going on. So I'm going to print x. So as you see, the first x is -1, and then negative 0.7, negative 0.5, negative 0.3, and then all the way it goes to 1. So I have like 10 of these X values. Now I'm going to kind of initialize, let me insert another code cell. I'm going to initialize X, Y, and Z matrices. These three variables are going to store the coordinates of the points that I'm going to draw a surface through them. So please note that this X here is small x. I'm going to use capital X for the actual coordinates. So to initialize these matrices, I'm going to initialize with the 0 values. So NP zeros. So I think I'm going to use, so these matrices, they have 10 rows and 3 columns. The reason I need 3 columns because I have, in each cross section, I have 3 points. So I need to store the X value for these 3 points. So I need to have 3 columns. And then I need to have 10 rows because in the other direction, I have 10 X values. So if I print this capital X, so you see I have initialized a matrix, capital X, with all 0 values. It has 10 rows and 3 columns. 10 rows because I have 10 cross sections along the x-axis, and 3 rows because in each cross section I have 3 points that I need to calculate the coordinate. So I'm going to do the same for y and z coordinates. So capital Y is equal to np dot zeros, and then L and 3, which is going to be 10 by 3 matrix. So let me print this. Okay, and then another code, capital Z is equal to np dot zeros, L and 3. I'm going to print Z. Okay. Now I'm going to basically start calculating the coordinates of these points and then store them in capital X, capital Y, and capital Z matrices. Okay, so I'm going to use loop. So for as a for loop, so for I in range, so I have 10 X values that I need to go through them. So it's in, so the range is over L. L is equal to 10. So the X coordinate, the capital X, is I, and yeah, it's I, and the colon there, it means that all three columns are going to have the same value. So all of them are going to be equal to X, I. So let me print X to see what we got here. I think I needed to define this. I think that was correct. Oh, I see what's going on. Okay. So I should put the printed statement out of the for loop. So I was wondering, why I have all these matrices. All right. Okay, there we go. This is the final. So previously I had this printed statement inside the for loop. So I had it printed 10 times. I just needed to print the final X. So this is the final X. The first row is all -1. The second row is all -0.7. And then all the way to the end, the last row is all 1. So this is good. Now I'm going to add to start calculating the y values. So the y values, so first of all, I need to create the y value for these 3 points and then populate it and store it in the capital Y matrix. So what I need to do, so the y value is 1 is 0, the other one is 1 minus x squared. The middle one is in between the two. So I'm going to first create a new variable called small y, which is MP. I'm going to use line space, and then it's from 0 to 1 minus x squared with double asterisk, and number of the points are 3 because I have 3 points here. So this line is going to create 3 values for y. The first one is 0. The last one is 1 minus x squared, which is this one. And I'm going to have a total of 3 points. So that means that the middle one is going to be in the middle at the equal distance from the 2 other points. So if I print this y value, you're going to see how it looks like. Oops. All right. Okay, so this is, let me put this print statement inside the loop. I think I just need to put it outside. Okay, it looks messy because I think each time it goes through the loop, it just store the y value. Oh, I'm sorry. I think I missed to put the index here for the x. Okay, now I should, if I print this, it's going to. Okay, this is just the final y value. If I put it inside the loop, there we go. So the first one is the first iteration. I have 3 zeros because it's here. It's here, and all 3 points are on top of each other. The last one is the same. All 3 points they have same coordinates. And then, so as you can see, the first one, the last one are all 0. And then the middle ones, the last value here on the third column is 1 minus x squared. And then the middle one is the half of that value. And then I have populated all the y values from this point, -1 to +1, this point. And I need to store it in a capital Y. So I should, okay, I need to store it in, it's a similar, it's going to be similar to this line here. So I'm going to store it in capital Y like this. Yeah, each line it goes in, and it goes into one line of capital Y. So it's like that. If I print capital Y, there we go. So this capital Y stores all the value for the Y coordinates. So 0, 0, 0, the last one is 0, 0, 0, and the middle ones are, the middle one's third column is 1 minus x squared, and the second column is half of that. That's good. Now we have, right now we have the x coordinates and the capital Y coordinates. Now we need to calculate the z coordinates. For the z coordinates, I need to do another loop. So this is going to be j in range 3. So the first loop, the outer loop, is from 0 to 10 or 0 to 9, 10 times. And then the inner one is from 0 to 2, 3 times. So what I have inside this loop is, this is where I need to decide which line I'm going to use. So previously we saw we have two lines. If the y coordinate is less than half a b, we're going to use equation for line 1. If it's more than half a b, we're going to use equation for line 2 to calculate the z coordinate. And here are the equation. If it's less than half a b, we're going to use this equation, z equal 2y. If it's more than half a b, we're going to use this equation. So we need the if statement here. If if y I j is less than equal half a b, and b is 1 minus x I squared divided by 2. Divided by 2. Yeah. So z and j is equal to 2 times y I j. Else z I j is equal to -2 times y minus 1 plus x squared. Y I j minus 1 plus x I squared. Okay, let me print z. Okay, this is, oh, I think I know what's going on. I forgot colon here. Okay, I think it looks good. I see on this last column, I should get all zeros. But I think these values are so close to 0, should be fine. One note here, instead of yij here, capital yij, I can use also, I can use yi or yj or yi, I think, yeah, because it goes from 0 to 3, so I can use yi. I can use yi here. I can use, I'm sorry, yj. Yj, and probably I get the same result. Yeah, this is the same result. Anyway, I'm going to put that back. Okay, now we have the coordinates of all the points x, y, and z. Now it's the time to do the magic and basically draw that 3D surface. So I'm going to insert a new code cell. So up here, we didn't import the library for drawing the 3D surface. It's just a math and numpy library. So here first, I'm going to import the library called Ployly dot graph objects as Go. So instead of this long name, I'm going to use Go from now on. So I put the link to this library. You can read this documentation here. There are all sorts of graphs you can plot with this library. This is very useful library. Specifically, I'm going to use the 3D surface method or function in this library. So here in this page, you can see several example several different surfaces that is drawn using this library. I put the link of these two pages in the description below this video. So let's go ahead. So this line, I'm going to import that library, and then now I'm going to start plotting. So I'm going to name that plot as fig. So I'm going to use Go library, and then so I'm going to use figure. Now I need to input data, and that data is equal to another function is called surface. So I think I have to use bracket here, go dot surface, and then I'm going to use parentheses. So inside the parentheses, I'm going to introduce x, y, and z coordinates. So small z is equal to capital Z. This is small z is like a default parameter for the function, is like an input argument. So y is equal to capital Y, and then x is equal to capital X. These is small x, a small x and a small y are different than this is small x and a small x and a small y that we define up there. Okay, so this is the figure, and then to be so if I plot this, there is no error, but nothing is happening because I need to show that figure. So fig dot show is the command you use to see the figure. There we go. So we have the surface. So there are a lot of customization can be done on this figure. For example, so I can say fig dot update layout. Wanted to make it larger, width equal to 800 and height equal to 800. Fig dot update layout. Oh, there we go. Okay, so this is larger. So there are a lot more goes into this layout. You can add caption, a label for the axis, all this stuff. I'm not going to go through all this. So this is the surface that we're going to plot as a 3D surface, and I think I'm happy with that. So there are a lot of different graphs, 3D plus that you can do with this library. So I leave the links for these two libraries, this library Ployly, so you can go through the examples and read, and maybe you can find something useful, and leave it in the if you want me to make another video and show you how you can plot something else, just leave in the comment section below this video. I make another video explain that. Thanks for watching this video again, and if this video is useful, please consider hit the like button, and also subscribe to our channel so you can get notified whenever we upload a new video. Until next video, bye everyone. Thanks.